Okay, hello. Precalc C. Last week we learned about parabolas and we had some homework. It was pretty short and I want to say it was pretty easy, so maybe you don't even need to watch this video. Or you can watch it on 2x speed or skip around to the problems that you find interesting. These were all just, basic kind of high school American math class problems about the conic sections, nothing sort of fancy. And okay, so here they were. Hopefully it wasn't too many, and by the time you were done, you understood everything about parabolas. Well, yeah, I selected these certain problems that I circled right here. I'm going to do them all right now. Let's go. This is sort of most of them, so possibly overkill. I'm going to just go kind of fast because I don't think I have much to say. X minus 1 squared plus 8y plus 2 equals 0. Well, this is basically already in the form that you wanted. This is, I hopefully copying the problem right? Yeah. So this is x minus 1 squared equals negative 8y plus 2. Okay. Well, this is superficially in the form x squared equals negative 4qy, and I know that, well, I guess I just learned this, so I just know it by heart now or something, that this is going to be it's essentially a y equals x squared parabola, so in other words, a normal one. So this is opening up, down, and the negative makes it down. So just generally speaking, if this is an x squared equals negative 4qy type parabola, then the vertex is at the origin in this case, which I sort of think of, and then it's a terrible looking parabola. But this is sort of the only stuff you need to know, that the focus will be q away. So that'll be 0, negative q, and the directrix is up here at y equals q, and the parabola itself is opening down. What are the actual tasks? Find the vertex focus directions of the parabola sketch. Okay, well anyway, this is not quite that, of course, because in fact the vertex is not at the origin. The vertex has been shifted by some amount. By how much? Well, over 1 and down 2. So this vertex is going to be at 1, negative 2. And you can see, because that's 8, that means that q is 2, the distance from the focus to the vertex, and also the distance from the vertex to the directrix. Okay, so let's make a kind of a real picture of this. This was all, everything here, which I'm about to circle in red, was not actually the answer to this problem. It was just me kind of remembering all of the knowledge I have about this. Well, let's go. I go over 1 and down 2. So there's my vertex at 1, negative 2. If q is 2, then it means my focus will be 2 below that. So my focus will be at 1, negative 4. And if q is 2, it means that my directrix is the line y equals 0. And thus, the parabola itself is going to look, however it looks. Something like that. That's good enough for me. Okay, so yeah, I wasn't joking when I said fairly straightforward. Alright, 1 down, many to go. Number 15. Alright, this is, I think, like kind of almost the exact same thing. So y plus a half squared equals 2x minus 5. Y plus a half squared equals 2 times x minus 5. Well, this is already in the exact form that I want it to be in, because this is going to be a y squared equals 4qx type parabola. And okay, this is kind of like an x equals parabola. In other words, it's a sideways parabola. So this opens right. Okay. And, well, I don't think I need to draw the generic picture again, because I think we remember what q is and everything. So what is the vertex for this particular problem? The vertex is going to be at 5, negative a half. Q is, if 4q is 2, then q is a half. And yeah, that's it. So, okay, let's graph it. what's it going to look like? 5, so 3, 4, 5, comma, negative a half, so boom. That's the vertex. And, okay, what did I say? This is opening right. Q is a half. So, well, picture's kind of bad, I guess, but that point is 5, comma, negative a half. And that's 6. Wait, what am I doing here? Y squared is x squared. X squared is opening right. It is true that Q is 2. 5 negative a half is just a weird point, but all right. And then where is the focus going to be? It's going to be to the right. So I guess that this is like 5.5, comma. So this is my vertex. My focus is going to be at 5.5, comma, negative a half. I almost don't believe that this could be the right answer. What a gross problem. And then the directrix will be here, and the directrix will be x equals 9 halves. Okay, I don't recall, I have no memory of doing a problem like this before, so it's possible that I made some kind of tiny mistake, but I can just check it in the back of the book really fast. I bet that's right, or I just made some tiny mistake. Both are possible. What is this, 10-1? Yeah. Good. What are we doing? Parabolas, number 15. Yeah, that's just right. 5, vertex 5 negative a half, focus 11 halves negative, directrix x equals 9 halves. Alright, great. Good. 2 down, many to go. Can I squeeze in one more problem on this page? I think I can. Or on this board. So let's see. Here's this number 20. So alright, 20 is going to make you, do some work. So y squared plus 6y plus 8x plus 25 equals 0. Y squared plus 6y plus 8x plus 25. Alright, so, well, this is exactly like the previous problems, but before I can do anything, I need to put it in a form so that I can understand what's going on. So, what do? We just move the numbers. Sorry, we notice that it's a parabola and that the quadratic variable is y squared, the variable which is which has degree 2. So we get that all by itself, and we move everything else over to the other side. Okay, that's what I want to do. Now I'm just going to complete the square here. So I add 9 and I add 9 over to that side as well. So, excuse me, this is y plus 3 squared equals negative 8x minus 16. And so this is really y plus 3 squared equals negative 8x plus 2. So now I know that this is a y squared equals negative 4qx type parabola. And this is opening left, therefore. This is a kind of an x equals y squared parabola, so a sideways one, but the negative means that. Okay, and then what else do I know about this? I know that the vertex is at negative 2, negative 3, negative 2, negative 3, and also that q is 2. Alright, kind of just bored already by this homework. I guess it's just not that exciting. So maybe I shouldn't have said that out loud. Negative 2, negative 3 is the vertex. Negative 2, negative 3. And then, okay, put that label in a bad spot because that is my vertex. Where is my focus going to be? Okay, they tell me to draw a picture, but I would just draw a picture anyway because I just think that this is a visual activity. So it's when I have plotted my vertex that I now begin to say, okay, this parabola is opening left, so the focus is going to be, right here. So that focus is at negative 4, negative 3, negative 4, negative 3, and it means that my directrix is going to be to the excuse me, to the right. So that's just going to be x equals 0. It's just the y-axis, and then the parabola itself will be opening left with -2, -3 as my vertex, and -4, -3 as a focus. All right, good. Do any of these problems get any more exciting? I actually think that they maybe don't. Okay. We push on. Yeah. Dead time. Okay, good. 23. I think 23 is just like annoying. I don't think there's anything deep going on here. So let's see. Y equals -1/6 x squared plus 4x minus 2. Okay, I think they're literally just, this problem is just designed to sort of piss me off. I don't know why I have such a bad attitude right now. I guess this is just not that much fun. Let's just do the only thing we can do, which is distribute. Let's see. I guess if I'm being kind of cool about this or something, I realize that fractions are what's bothering me. So let me multiply both sides by -6. So I get -6y equals x squared plus 4x minus 2. And I'm actually just already happier because this is really x squared plus 4x equals, adding the 2 over to the other side, -6y plus 2. Okay, so -6y plus 2, x squared plus 4x. All right, great. Now this is just kind of like a normal problem. And by that I mean I need to complete the square. So I add 4 to both sides here, and that gives me then x plus 2 squared, and this is -6y plus 6. So really this is x plus 2 squared equals -6y minus 1. Alright, so that's just the equation. So I guess if there's any points to this problem, it's just to get you to be comfortable algebraically manipulating parabolas in whatever form they might come in into the form that we really want, which is this one. And alright, what do I see from this? I see that this is in the form x squared equals -4qy. So this is another up-down parabola, and the existence of the negative tells me that this is opening down. And the vertex will be at -2, 1, because it's being shifted to the left and up 1. Also, if 4q is 6, then q is 3/2. So I believe the directions are exactly the same. Find the vertex, focus, and directrix of the parabola and graph it. Okay, they say use a graphing utility, but that's a ridiculous thing to do. So -2, 1 is my -2, 1 is my vertex. Where is my focus? Well, if this thing is opening down, then my focus is going to be 3/2 away from that in the down direction. So it's going to be right there at -2, -1/2. And where is my directrix? It's going to be 3/2 above. So boom, boom. So right there at y equals 5/2. If I'm doing that correctly, yeah, I think I am. And the parabola itself is going to just be shot. Okay, good. So basically all of these problems so far have just been getting comfortable with the 4 formulas and just kind of applying them. So not too deep or anything. 30, I believe, is more of the same. Yeah, this is just I'll just say this is just great practice. Vertex 3, 2, focus 1, 2. I don't know whether you guys like it better when math is really easy but kind of boring, or really interesting but hard. I guess pros and cons of both. This is easy and boring. Vertex at 3, 2, focus at 1, 2. So we go boom, 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 boom. So 3, 2. That's my vertex. My focus is at 1, 2. So that means that this parabola is going like this, and directrix will be over here at y equals 5. Is that Sorry, 1, 3, 5, yeah. Okay, great. What am I supposed to be doing in this problem? Just writing the equation? Yeah. Well, not that hard, right? Opening left parabola. Therefore, if it's opening left, then I know it's going to be one of those y squared equals negative 4qx type parabolas. This is how I think about it. And now I just adjust it for the fact that, in fact, the vertex is at 3, 2. So that's going to be y minus 2 squared equals, q is just 2 here, so that's just negative 8x minus 3. So that's all there is to say about that problem. Should we do just 31, just like while we're here? No, we really don't need to do 31. 34 and 42, and then we'll call it a day. Maybe I'll just squeeze 42 in right here, because I think that's pretty short. 42 says, highway design. Highway engineers design a parabolic curve for an entrance ramp from a straight street to an interstate highway. Find the equation of the parabola. Alright, this is just a perfect example of just crap problem that just pretends to be like about something, but it's just not about anything at all. So instead of just giving you an equation for, instead of just giving you a picture of a parabola and telling you to find the equation of it, they wrap the problem in some kind of totally meaningless thing that's supposedly about the real world. Like, this is a parabolic curve for an entrance ramp from a straight street to an interstate highway. So like maybe like this is the highway and this is the street, and so they make the ramp in the shape of a parabola. But okay, I mean, you know, come on, man. You might be thinking, Mr. Rose, why did you assign this problem then? Aren't you like the teacher or whatever? Yeah. Good. Let's just find the equation of this parabola. What is it? Well, maybe that's a little bit of a harder question than it looks like. But maybe it isn't. Well, first of all, it's just drawn. I suppose I'm just supposed to look at it and see that the vertex is at the origin, and it's also opening right. So if this is opening right, then this is going to be a y squared equals 4qx type parabola, because x equals y squared parabolas are sideways, and this is opening right. So in fact, because the vertex is at the origin, there's only one thing to do, which is to find q. And how do I find q? Well, I can just plug in these numbers. Since I know that 1000, 800 is a point on the parabola, then if I simply plug that in, then what am I going to get? Well, I'm going to get 800 squared equals 4q 1000, and I just need to do that. So what is, let's see, I guess there's a bunch of ways to do this, but what is 800 squared? Well, it's 64 followed by 4 zeros. And then I'm dividing by 4,000, so maybe there's a cooler way to do that, but this seems good to me. Jump, jump, jump. And 640 divided by 4 is going to be 160, I guess. So q is 160, and therefore this equation should be y squared equals 640x. That doesn't strike me as super familiar. I will just look that answer up really quick to avoid potential embarrassment if it's wrong. But I bet it's just right, because it seems like the kind of thing that would be right. Yeah, y squared equals 640x. Okay, good. Good. Well. Yeah. Alright, one last problem, which is number 34. Let's do it. This one is a little bit harder, but it's not really a deep problem. It's just, algebraically, it's just challenging. And it's maybe a little bit of a bad problem, because you can kind of guess a little bit. Okay, so 34, and then this will be the last one that we do. Time check. Yeah. Good. Sorry, 34. This will be the last one that we do. Okay, here's what they tell us. The axis is parallel to the x-axis, and passes through the points 4 comma negative 2, 0 0, and 3 comma negative 3. Alright, so there are basically 2 ways to do this problem. First, let's make a picture. Okay, well, if it's parallel, well, okay, let's plot the points first. So here's 0 0, here's 4 negative 2, 4 negative 2, and here is 3 negative 3, so like this. Alright, if you're willing to take some kind of guess, which I'm not willing to do, then we can probably guess what the equation of this parabola is by just looking at it, but that's sort of against the spirit of the problem. Let's use the information given to find the equation of it. And the problem is that I don't know, well, it's parallel to the x-axis, so that means it's going to be some kind of sideways parabola. So I just don't know what kind. So I have to kind of imagine that it could look like anything, but it's going to be like that. All right, so really this is just kind of an algebra problem. You know, find the equation of the sideways parabola that passes through these 3 points. And basically, you have 2 ideas. One is to treat this parabola for what it is, which is a sideways parabola. So it's going to be of the form. Y squared equals 4qx, but specifically y minus k squared equals 4qx minus h. So y squared equals, so there we go. And it strongly seems, based on the picture that I've drawn, that it's going to be opening left, but okay, here I will allow for q to be either positive or negative. So I have 3 unknowns, basically, which is that I don't know what k is, I don't know what h is, and I don't know what q is. But these 3 unknowns are going to be perfectly matched by the 3 points that I have, and so I just set up a system of equations in 3 variables and I just solve it. This will work, but this is kind of a drag, because it's kind of a drag. It's a slightly smarter way to do this problem is to not use this form, but to just kind of know that, you know, this is a sideways parabola. So what does that really mean? It means that it can be written as an x equals and then some quadratic in y. In other words, it's much kind of smarter to set it up like this algebraically. And after all, any equation like this, okay, this is just a quadratic, this is just a parabola, we know that, so this is just going to be the generic equation for a sideways parabola. And there's actually no difference between these 2 approaches. This is just going to be a lot easier because I just get simpler expressions, and it's still true that 3 points are going to enable me to find the 3 unknowns. But now, for example, the fact that this parabola goes through 0 0, when I plug that in, I just immediately get that the only way for that to be true is if c is also 0. Now, I'm doubting that this could be so simple, but it just is, right? Yeah, it just is. So plug in 0 0, and what do we get? We get that c has to be 0. Plug in 3 comma negative 3, and what do we get? We get that when when x is 3, so 3, I should put a kind of a colon here, is when I plug negative 3 in for y, I get 9a minus, plugging in negative 3 for y, 3b plus c, but c is 0, and then when I plug in 4 negative 2, sorry about that, when I plug in 4 negative 2, I get that when x is 4, y is negative 2, so I plug in negative 2 for y, and I get 4a minus 2b equals plus c, but c is 0. So I guess the advantage of doing it this way is that the 0, 0 point immediately kills that c. Alright, anyway, now I just have to solve this system of two equations in two variables. What's the simplest thing to do? Well, I guess I'll multiply through the first equation by 2. So that gives me 18a minus 6b equals 6. And I'll multiply through the second equation by negative 3. So that gives me negative 12a plus 6b equals negative 12. And if I add them, then I get 6a equals negative 6. And so a is negative 1. And if a is negative 1, then negative 6 equals negative 3b, and so b is 2. Just to make sure I'm not too hasty there. A is negative 1, negative 6, add 9 to both sides. Sorry, a is negative 1, negative 9. No, I think I did mess that up. If a is negative 1, that's negative 9, add 9, so 12 equals negative 3b. So b is negative 4. Let's see if that just checks out really quick. So that's negative 4 and 8 is 4. Yeah. And negative 9 and 12 is 3. So there we go. So a is negative 1 and b is negative 4. So what does this tell me? This tells me that x is just negative y squared minus 4y. Actually, just that's it. Okay, what's so good about that? Well, on the one hand, I'm done. If I want to make some kind of sense of this, then I should multiply both sides by negative 1. So that's y squared plus 4y equals negative x. Now I will add 4. And I'll add 4 over here as well. And now, writing this as y plus 2 squared equals negative x minus 4. This tells me what I need to know. That this is a sideways parabola. It indeed is opening left, which my picture suggested. And the vertex is at 4, negative 2. Okay, so that's very plausible based on this picture that in fact this is the vertex, and you wouldn't have known that. Alright, so that's probably just the place to stop. If you want to see what it would have looked like to pursue this method, it's just going to be like worse, right? Because when you plug in 0, 0 for x and y, what do you get? You get k squared equals, when you plug in 0 for x now, you get negative 4qh. That's my first equation. Then my second equation is what happens when I plug in 4, negative 2. So now plugging in negative 2 for y gives me negative 2 minus k squared equals 4q 4 minus h. And my third equation, when I plug in 3, negative 3, make sure I don't mess this up, y is negative 3, so that's negative 3 minus k squared equals 4q 3 minus h. So I still have 3 equations in 3 variables, but it seems much more difficult to solve this system of 3 equations in 3 variables. And in fact, I don't even remember how to do this. Oh no, I guess I want to like cry is what I want to do actually. Okay, I kind of know what to do, which is you write this out as negative 4qh. That's negative 4qh plus 16q plus 16q. And over here you write this out as negative 4qh negative 4qh plus 12q. But then negative 4qh is just k squared. And so you get now two equations in two variables. You get negative 2 minus k squared equals k squared plus 16q. And over here you get negative 3 minus k squared equals, in place of that negative 4qh, I also put a k squared plus 12q. Okay, and now from here, I guess you just crank it out. Maybe you move the k squareds over and you do some more things or subtract or who knows what. But I don't really want to do this, so I did it the fast way. Okay, goodbye. That was Parabolas.